Hello, everyone, and welcome to today's Insight Live, IT Experts Take. My name is Jason Rader, and I'll be your host as we talk about the interesting topic of expanding your horizons, growing your business with Intelligent Edge. I have two brilliant folks with me, and we're going to have a great conversation about this. I'll let these guys introduce themselves. Amal, why don't you go first, and then Andy, you follow.
Sure. Hello, everyone. My name is Amol Asgaonkar. I lead the Intelligent Edge strategy for Insight. Andy?
Yeah, I'm a principal architect for.
Andy, are you on
You might have just gone out. We lost your audio, Andy. But principal architect was in there.
Nope.
Not yet. Well, we talked a little bit earlier about how we were going to kick this off, Amal, and that this might solve that problem. Because we talked about like redefining what Intelligent Edge was for everybody out there. And that was a thing where we joked that maybe if I asked you and Andy separately, you guys might give different answers. So we'll actually put that to the test. So when we're talking about Intelligent Edge, and that term's been used, we used it last year in several sessions, but the 2022, what are we talking about when we're talking about Intelligent Edge from your perspective? And then we'll let Andy see if he gets it right.
Perfect. So from my perspective and what I've seen talking with customers, Intelligent Edge essentially means bringing that intelligence, that compute, your processing closer to where the data is being generated. So traditionally, data gets generated, let's say on a manufacturing floor, in a retail store, or outside somewhere, right, in a farm. And all of that data then moves to a data center, or it moves to the cloud. And then you get your processing and then you access it, right? There is lag, latency, all of those issues. So Intelligent Edge for me and talking to the customer means bringing that processing or some part of it right down to where that data is generated so that you can analyze the data quickly. And first of all, huge amounts of data is being generated, right? So if you compare to what is being generated now versus what was being generated 5 years ago, even, it's multifold increase. So analyzing that much data, it's better to do it there. So you can get your insights, you can get your trends, the tidbits, the decision-making power right then and there, and then decide what to do with the rest of the data, right? Once you've analyzed it, do you want to keep it or do you want to just discard it? And then that comes into the decision-making where whether you really want to keep that data or not keep that data and whatnot. But you get your trends immediately. You get your decision making right then and there. And that, for me, is the Intelligent Edge. But of course, it does expand into where that edge is, right? That edge could be the networking edge. The edge could be the data center, right? It could be anywhere. But essentially, trying to bring that compute closer to where the data is generated and then bringing intelligent applications to run there is the Intelligent Edge for me.
So let's see if you can hear me now, guys. Is this better?
We got you now.
So I have intelligent microphones that load balance. So the Intelligent Edge, I'll echo exactly what Amal said, but I look at it from an infrastructure lens. So one of the things that we've struggled with forever in IT is latency, is what Amal's talking about. Bandwidth, we keep getting more and more of, but latency is dictated by the speed of light. So what Amal is talking about is if I have data that needs low latency processing and quick turnaround time on decision making, like he just said, I can't do that over a WAN very easily. I can't go to and from a cloud vendor too easy. So I have to take some of that goodness that we have in the data center in their cloud and slowly move it out to a remote location like he's talking about. So from an infrastructure perspective, the Intelligent Edge becomes very interesting because no longer is it a little entry-level device that's talking to a camera or a sensor. Now we tend to have storage, we tend to have compute, we tend to have acceleration. So GPUs and DPUs and FPGAs, all these acronyms that we talk about, but that edge goes from a little Raspberry Pi like this to something big and beefy. And it's related to everything Amal just said from a software perspective, but it's all dictated kind of by that speed of light because I can't pull it back to a data center. I can't totally do the processing in the cloud. So same thing. We said the same thing, two different ways.
Well, that's interesting. Maybe this is the first time, Andy, you and I have agreed on something.
Sure. Just the terms are different.
No, and I think, I'm glad that I think you both did a good job explaining that whole intelligent part of it, because I think the edge we've joked about where the edge is, and it depending on the scenario that we're talking about, it could be in different places, to Amal's point. But that intelligent part is, the processing needs to take place closer and closer to where the data needs to be used, and pushing out, and the applications have to be developed appropriately to take advantage of that, and the infrastructure has to be appropriately designed and implemented to be able to support that. So I think, and I don't know that has changed since last year, but I think it's a good level set to talk about it again, and get everybody who's listening out there, and thank you for all your comments and suggestions, everyone out there, to help everybody kind of level set as where we're going to go. Now, we talked about expanding your horizons in the title here. So what are some of the newest things that folks are doing now? Because it takes a certain amount of time for people to kind of get comfortable with the capabilities. And, there's those bleeding edge folks that kind of set the way that a lot of folks are going to follow. What are some of the cooler things that are going on out there from an intelligent edge perspective right now, gentlemen?
So I think it differs from industry to industry. But if you look at, let's take manufacturing, right? And in manufacturing, computer vision is now coming up, where they're using cameras, and maybe existing cameras and not specialty cameras, even existing, maybe the security cameras, to do some analysis of how their space is used. Maybe there are some specialty cameras that they can put on assembly lines that can detect anomalies on their products. So they're trying to reduce the workload of their employees that are trying to do the same task over and over again, and try to automate that, and then use their expertise somewhere else, right? So they can build and become more efficient. So I think the interesting part here is just being able to use your existing hardware and bringing that intelligence closer to it. I see that happening again and again, customers asking for the same sort of solution. So there's a very common pattern that I see in computer vision is you've got your cameras, then you have your compute, you have your storage, your networking layer on top of it. Security is always important, right, across the board. And how do you architect that? And then talking about the business outcomes that will drive. But if you look at the common pattern, it's the same. It's some specialty camera or generic off-the-shelf camera that you take, your AI models that you have to build, and then your business outcomes. So if we can essentially make it easier for customers to use it, then it's going to be more adopted. Right now, there is a big learning curve because it's not very clear. It's not straightforward as that you just build an app and it's done, right? It's not that straightforward. So there's a lot more involved in it.
Well, to pile on to that, the form factor. So to what he's talking about, he said, off-the-shelf cameras and this, that, the other thing. Initially, people do these projects with commodity gear. But the other thing that's starting to happen in our industry is exactly what Amal said, is that's great for POCs and for initial deployments and for ROI building and all that stuff. But what we're seeing in our industry is better form factors, better devices that consolidate into a tighter footprint that's easier to manage. And that's the part that's I'm super passionate about, being from the infrastructure side of the house. Is I don't want to deploy a router and a switch and access points and all the complexity of management around that at a small remote site. I want that to be a nice little package in a bow. And oh, by the way, if the cameras can be integrated into that, cool. We're starting to see some of the camera vendors that are allowing fleet management type capabilities, because once you build the ROI that Amal's talking about, you come up with this great use case that works great in 4 facilities. Now, how do I roll it out to 400? And that's where we're seeing kind of the next wave of infrastructure and tooling, both software and hardware. So that's the part that I'm paying a lot of attention to.
And to talk more about infrastructure, I completely agree. I mean, there are different form factors, right? So earlier, everything was thought of like, I need huge compute for this to happen. Maybe not, right? You look at the use case, and if you distribute it enough, you might get away with smaller form factor, and then have an aggregation point at the edge itself, which is a bigger compute, right? So you could have something like this with its fanless, heat sinks, run a small use case on it, and then that takes a chunk of or slice of the data, processes it, sends it to your aggregation point at the edge, and that becomes your, almost like a smaller data center, right? Data center when I think about data centers, I think about this massive stuff, but that's what I'm saying, like a tiny data center that you could have a cluster of machines running together to provide that higher ROI for you.
Well, and Amal brings up a neat point too, is we talk about this is the whole mainframe to open systems thing that we did 20 years ago. It's happening now with compute. Is we're seeing resources shift from the data center and the cloud out to the edge for good reasons, like we're talking about. And so it'll be fascinating to see how much lives at the edge and how much lives in a data center. And you have to be very pragmatic about it, figuring out where the processing needs to be done, like Amal said. And that's where that whole form factor thing is interesting, because I'm not putting a mainframe-like box out at the edge, but I don't get a whole lot of horsepower out of a little entry-level Raspberry Pi. And we have all these neat form factors in between. Sorry, Jason.
No, we're all playing off, because you guys answered or talked about exactly what I was going to ask. Because I think when we talk about intelligent edge, just in the examples that you guys just gave, the amount of intelligence required in the device depends on how the application is developed, and depends on what other things sit at the edge, whether you have that aggregation point or not. So maybe instead of having a more advanced camera with its own onboard processing, you can take what comes in cameras and send them somewhere else to be processed by a GPU that's designed for that, but still at the edge. And again, then you have those separate centers of data that would eventually, reconcile that depending on what the application is trying to do. So it's, you can have intelligent edge with different degrees of intelligence, was the point that I was trying to make.
Yeah, it's almost distributed intelligence, right? So you're
exactly
trying to make sure that if because different decisions can be made in different sections of the same plant,
and should be,
right. So based on how those are consumed, right? So if a decision is made by a system, an AI model, or what have you, an application that's running at the edge, connected to maybe one PLC that's giving you vibration data from a motor and heat dissipation, and it tells, well, this is not normal, something's happening, right? So you have to, at the end of the day, somebody has to consume that data, that decision to say, I need to do something, or an action has to be put in place where it'll either stop it or do, like, turn on a signal light or something, right? That tells people that something's happening. So that communication is also important. And that's why the distributed intelligence will be helpful. So it's not dependent on that one system to do its job for it to tell you, right? It could be then and there as you're walking on the manufacturing floor, or you're walking through a retail store or a mall or a parking lot, and it's telling you then and there, like, hey, this is a problem, you need to solve it now. I think that's the real power of intelligent edge, is it's connected, it's distributed, but it's not centralized, right? You don't have to depend on this one monolithic application to do something for you, and then you get your decisions out of it.
Well, think about like a semi-connected solution. So we're starting to see that too, and that plays exactly into what Amal's talking about. So oil rigs that are on and off the network, or the one trend that's blowing my mind a little bit right now is this whole tiny ML, which is kind of the opposite of intelligent edge, but not really. So tiny ML is embedding decision making, like Amal's talking about, into the spare cycles of a camera or of a PLC, and that's super necessary if it's totally disconnected. If we have a sensor that's sitting on a glacier in Antarctica that's not on a network regularly, then it's almost the same intelligent edge-like architecture with just a different power consumption, a different footprint. And I find that really fascinating. Mobile workloads. We see a lot of onboard trucking workloads, and they don't always have a 5G, 4G connection. And so you look at those trucks, or you look at those trains, or you look at those mobile units, and they tend to have a little mini data center, in a box strapped to the big rig or strapped to the train for all of those semi-connected reasons. It's really cool stuff.
I think to add to that, I think there's another trend that's happening, but I think it's on the software side enabled by the hardware, is when you're running all of these AI models, now there are software stacks that would determine what hardware do you have. So you have CPU, you have iGPU, and you have a GPU, and you have an FPGA. Now, based on what I'm getting, they can switch between those as needed. So if I'm running an AI model and I say, okay, I'm getting another AI model that I have to run, well, I have a GPU out here sitting there with none of the scores being used. I'm going to delegate or use those, right? So it's amazing how a use case or technology is affecting so many different stacks, right? It's not just software, it's hardware, it's networking, because now guess what? So much data has to move. What is it moving on, right? So having that is amazing.
You're tracking exactly with what, and I'm excited about this conversation. We didn't necessarily rehearse all these questions, but when you're talking about what you just did with the leveraging processing power of the different portions and pieces that exist at the edge, I was going to ask, and I'm pretty sure I know the answer, but it seems like you don't just design the software with this abstraction regardless of what the hardware is. You've got to design it so that, based on the different types of hardware that exist, which means that folks like yourself, Amal, and then folks like yourself, Andy, the infrastructure and the development side have to be coordinated.
Right. So there are certain software stacks that are built with a specialization, right? So you give them an AI model and they know exactly how to run it on a GPU, whether it's NVIDIA or any other. Do you run it on an iGPU or a CPU or accelerate it with OpenVINO or any CUDA or whatever, right? So they know how to do that, but that makes our lives easier. So from a hardware perspective, I can put in all of this stuff knowing that I can leverage all of this hardware as needed by defining it in the software. So I can then at runtime say, hey, use my GPU, use an iGPU, use an FPGA, right? And it can switch between those two or three. So that I think is super powerful, because like we said, the form factor will keep on changing, but I don't want to develop a separate snowflake solution for every hardware that comes out.
It's not like we haven't had GPU shortages the last 2 years either. Yeah. So go figure.
Yeah. And that's a great, and that was what I was kind of driving at is, so in 2022, when we're talking about the edge and the devices there, those devices and the software platforms that we're designing, they have this awareness of what's going on and moving forward. They're designed appropriately so that can happen. So the infrastructure can change without the code necessarily having to change.
Absolutely. And that I think is a real power, because you can then take your same stack, same software, right? Whatever containers you have, you can run them on a really small device like this, or, Andy's Raspberry Pi, if you wanted. And it would understand like, oh, I don't have a GPU. I have a CPU. I'm going to run everything on the CPU then, right? But you take that same stack and move it to a bigger compute with dedicated GPUs and an iGPU or multi processors, and it knows, well, I've got all of this horsepower now. I'm going to start moving it out. And suddenly you start to see, if it's a camera, you start to see the frames per second processed go up. Your heat dissipation will also go up. But then you start to get more throughput out of it. But from the software point of view, and this comes back to like DevOps and MLOps and AI ops, is it helps them manage all of this, and they can move those workloads around, because otherwise it would be difficult to start defining snowflake solutions for every type of hardware that's just built only for that. And now you add another GPU to it, like, oh, it doesn't work. So.
Got it. And Andy, I think, to that point, if that means that when you can develop in a lab and you can use certain types of hardware, but then move that code into production, completely different infrastructure. And, I know you have some words of wisdom for folks where that infrastructure should be validated in the production environment as well. It's got to be amped up for all of the capabilities that exist in that production environment.
Well, it kind of depends, but I agree with Amal is that he used the words containers. Things like Docker and Kubernetes is huge in these architectures, not because it's the end all be all for the edge, but it's for exactly what Amal said. It's portability. I can have small, medium, and large T-search size like architectures, but if they're all leveraging a container like architecture at the edge, that makes Amal and his software developer peers their life easier because they can deploy the same container, and the only difference between the hardware footprint is basically what are we trying to do with it? Like Amal was talking about, do I need video processing? Do I need local storage? Do I need horsepower? Or can I get away with something really small? The big hot button for me, though, and Amal started the conversation talking about managing at scale. Managing at scale is probably the biggest takeaway from this conversation for anyone listening is IoT is easy with 3 cameras. IoT is hard with 3,000. IoT is easy with 3 sites. It's really hard with 3,000. And it's not something new to our industry. We've managed remote sites. We've managed remote devices, but IoT puts that on its ear. And the reason this is important is I come from a utility SCADA background. SCADA was interesting because it didn't introduce a whole lot of variability. Most SCADA vendors standardized on specific meters, specific PLCs, specific things to keep that complexity down. Well, with IoT, that's where you start, but it's not where you end up. You end up having multiple generations of gear in the field. You have multiple form factors because of what Amal's talking about with multiple use cases. And so that management at scale becomes really crucial, both hardware and software. And I'm going to play into your background, Jason. We haven't talked about the S word much, but security across this whole thing at scale is a nightmare too.
Well, no, that's a great point. And I think, I always talk about we get all excited, and especially folks like us, about whether we can do something, but then there's the after we've done it, the operationalization of it all. And sometimes people don't think about, can we do this securely on the front end of this? That's something they might consider somewhere down the line. They might develop the code securely, but like the operationalization of it and where it sits and how it's processed and the data that it's using can potentially put you in a situation that makes it a completely different security situation than what you were thinking about.
Even this little Raspberry Pi, upgrading code on it is non-trivial, right? Even though it's a little simple device.
Yeah, it's true. But I think that's, you bring up a really great point, Andy, is that whole, thinking beyond whether we can do something, but how it's operationalized, how it's managed, that whole aspect, because you're right. I think that's, rolling something out that changes the world from your perspective in your organization. It makes you this productive. But then as you start figuring out as devices break and as you have to replace them, or, something like the Log4j vulnerability comes into play and you've got to update code across everything, that can be life changing. And if you have no mechanism to do those updates, that could really crush you.
Well, and the flip side to this is AI and the edge can be a huge competitive differentiator in a lot of spaces. So the ROI is huge, but if I've got to go turn it off because of a security hole, that's challenging. Go ahead, Amal.
Right, and it's not just updating the code; it's also patching those machines. Now you've got and now patch those machines and then roll out those patches consistently and make sure everybody's at the right level. That scares me, right? I mean, I can write code all day and make it secure. Great. Somebody tells me like, hey, why don't you patch 10,000 of these devices? I'll be like, yeah, I'm not happening. So,
and you have to do it this week or you're out of compliance with whatever business you're in. Yeah.
So that's the scary part. So I think having that security mechanism, having those right processes in place of managing these devices at scale, like Andy said, being able to monitor those devices, not just from a is this up or down, but how am I doing with my CPU, GPU, storage, other metrics, and being able to understand whether certain machines might actually fail, being proactive and going and replacing those machines as well, like the lifecycle services that go with it.
So what you're saying is we need predictive maintenance for the predictive maintenance infrastructure.
Right. It's almost like a predictive maintenance for the business use case, and then you've got the predictive maintenance for the actual devices that are giving you the predictive maintenance for the business use case. It's
and I was going to jump on and say that's another level of intelligence at the intelligent edge, is being able to use that, and probably should be included in our definitions as we move forward, because I think that's a key.
The intelligent edge. There we go. Well, and not to be Debbie Downer here in this conversation, but I mean, the use cases that we've done for clients justifies all of this and then some. I mean, in a lot of industries, especially industries that can't hire people and can't keep staff on board, we've got lots of really unique cases where AI and ML and an intelligent edge can replace a whole bunch of employees, or at least augment a whole bunch of employees. I mean,
or let them do better things than what they were doing, right?
Yeah. Totally worth the effort on the IT side or the OT side.
And I think,
go ahead.
we've said AI and ML a couple of times, and I wanted to kind of, what's the difference between AI and ML and intelligent edge?
So look at AI as a broader term. ML is part of it. So same goes with deep learning networks or neural networks is again part of that, right? And then so it's basically you're talking about a superset and then a subset of that term. And then once you have what is the other one that you want?
Intelligent edge. So I mean, AI ML is a strategy that isn't location specific, whereas intelligent edge is much more location specific. We're taking what we used to do in a data center or a cloud and put some subset of that, to use his term again, some subset of that out at the edge. And it's to enable AI and ML and other things, like what we used to do 20 years ago with a remote office with a file server and a database and things like that. To some degree, that's sort of intelligent edge for a different use case. So intelligent edge just means infrastructure and intelligence and functionality out at the edge, but AI ML is generally a use case that we see, not always, but generally side by side.
Think of it as is bringing the intelligence part of that intelligent edge, right? So one way to bring intelligence is maybe using ML or neural networks or in general AI back there. Otherwise, other means could just be a simple application running there that is deciding whether certain things are right or wrong and just letting you know, right? So it's not that you always need to have an ML model or a neural network or something like that running. A simple anomaly detection, not even looking at time series, is just looking at the current values, like is our threshold, like is this above this or below this? If it's above this, I'm going to freak out. I'm going to tell everybody that this is way above this. Do something for it, right? Simple. Maybe 100 lines of code and you're set. It's still intelligence because somebody can actually use that to make a decision to do something, right? Actionable intelligence, essentially.
I like that. And that was just, again, I love the buzzword bingo, but I like to kind of clarify to the folks that are listening, you can have intelligent edge without AI, but intelligent edge enables AI to be able to operate and then enhances the intelligence that you can have at the edge. I think is probably fair to say.
The other thing to keep in mind is when you use or run ML models or any of the AI stuff at the edge, you now have to think about, like you think about DevOps, right? You think about, okay, I've written a code, now I've updated the code, I have to deploy the code. You have to think about the same for ML models as well. You build a model with the training data set, you've tested it, looks great, you've deployed it, it's working, and now your incoming data set might change because conditions have changed, or maybe you've introduced a new product or something, right? So now you have a new training data set. Now you've built a newer model, right? Version 2.0. How do you make sure that this 2.0 actually gets down to the edge? And now you've got two models, version 1 and version 2. So how do you test between
with different potential outcomes depending on what's going
exactly.
on?
And so now you have to make sure that they're either for some time both are working so that you can contrast and compare. Like, am I getting better results out of 1 or 2? Is 2 better, really better? Or is it just because I've trained it a little more with newer data, I'm getting different results? So that decision still has to be made. And once that decision is made, you should be able to say, you know what, Chuck 1.0, 2.0 is great. I'm going to keep 2.0. But this is just not for one device now. How do you now take that model and deploy this to hundreds of devices that you might have out there in the field, right? So there's a whole ML ops pipeline that you have to work with and design to make sure that you can consistently update these models, make sure everything's coming in and being processed, gives you an opportunity to make that decision whether your older model was better or worse than the current one. So DevOps is, like, everybody knows DevOps. Everybody's now gotten used to it. MLOps is still out there, and there are chunks of functionality that you can pick and choose and try and put it together. But there's still a lot of work that needs to be done to really have that complete life cycle of an ML model, especially in the intelligent edge space. When you're running in the cloud, it's much easier. When you're running at the edge, you just added a layer of complexity in there.
And, you know, kind of to wrap up, or heading towards our wrap up, is there, we've talked about some advanced stuff, you know, development, infrastructure, operationalizing things, code updates, all of these things. Is the barrier of entry to this only for enterprise organizations? Who can play this game?
I would argue that almost anybody can. So if you have data that can be actionable, like Amal's talking about, you can benefit from this. Now, the difference being, what's your investment, how complex it is, that varies by industry, by customer size. But almost anybody that's in an industry that's generating data in some fashion can generally mine it, get more information out of it. And if I have a distributed architecture, then the edge plays into that in some fashion. So, and that's what's so cool for me. Yeah, go ahead.
Yeah, and Andy, I think literally anybody can start with it, right? If you don't know what edge is and you want to, let's say, start with computer vision models or some models. Let's take computer vision. Take a webcam, you know, take an off-the-shelf model like a YOLO V2, V3, V4, V5, select anyone. There are tons of these code repositories. Take that, run it at the edge, and it'll start working for you, right? And now you've at least got a flavor of what it is and why is it so powerful. So if you understand that, right? So small, medium businesses, mom and pop shops, to large scale enterprises, everybody can actually leverage this. And the ROI just depends on what the use case is. What are you trying to solve? And that will tell you whether the investment is justified or not. And to Andy's point, it doesn't have to be huge infrastructure. You could take a small device like Raspberry Pi or a small i3, i5 Celeron, take that and run with it, right? So
a really neat use case of this is, and I'm not trying to plug any vendors, we try not to on this, but we've got a lot of retail partners that have Meraki. Meraki has a really neat integration with their cameras. So if I'm running a coffee shop and I want to know how many people I have in my coffee shop during the day, and make decisions on that, Meraki does that almost out of the box with their camera stuff, that you can do people tracking and capacity tracking. And for somebody that's, and the reason I bring up Meraki is because we see that in a lot of little mom and pop coffee shops. That's not a huge leap to talk to their back end and extract that data and get some value from it. I love the AI ML conversation. I know we're talking about edge, but AI ML for industries that weren't very savvy at the edge, think traditional retail, they tend not to have a whole lot of infrastructure out at the stores because they didn't want the operational overhead. But doing heat map tracking, people tracking, I'll use the example of inventory control, but a lot of them are able to take their security cameras and do inventory control on the shelves, like teach it that when this part of the shelf is empty, that means we need more toilet paper. That's never happened this year. That kind of stuff can be automated in a really neat way and have huge ROI in an industry that wasn't generally technically savvy at the edge.
No, I love it. And that was the great point that I wanted to bring out is we talked about expanding your horizons. This isn't just for a select group of folks or a specific industry. This is for everybody. And even the smallest mom and pop shop can leverage this capability to make them more productive in other areas, especially if they've got low head count and have people that need to be doing other stuff. And I think it's hugely valuable to have that information about how many people come in on a Tuesday at 10 o'clock. Do we need more staff and those kinds of things, and to make decisions based on that kind of stuff. It's without having to have somebody, keep a manual tally or do some other kind of mechanism.
I just want to know when toilet paper's in stock. That's all.
Yeah. Or those GPUs we're looking for.
Yeah, that's
Well, gents, it's been a really great conversation. I think we need to have a few more of these sessions and talk about some specifics. What would you like to leave the folks that are out there looking to expand their horizons with Intelligent Edge? Some parting thoughts. Andy, why don't you go first?
I like Amal's call to action on think through a use case or think through something that your business or your entity could do in a POC or a proof of value to generate some ROI. That's the first step in this journey.
And if you just want to play around with technology, like we all do, just take any camera at your home. If you have a security camera at home, try it out. Right? You have a laptop. That's your edge. Build this out, run it there, and see. It is exciting. It's amazing to see what technology can do with how little horsepower, right, or compute, what you can achieve. So I would encourage people to just go and try it out. When you get into a professional or business setting, look for the ROI, look for a problem to solve. And the best way to look at it is anything that is done in a repeatable way. Somebody's doing it day in and day out, every 5 minutes. Think about automating that. And now that can be automated in a variety of different ways, right? Even if it's a manual task, and you're doing with your eyes, you're doing with your hands, anything, we can automate that, right? So think of it that way. That'll give you a lot more ways of building your ROI, building a use case for it, so that you can hash out exactly how much either you will save, make, or have a difference in the market with a solution in that. So.
Fantastic. Well, I mean, we're at a really cool point in the technology ecosystem right now. I'm excited about all of this stuff, and thanks, gentlemen. You guys were awesome to talk to about this. Amal, Andy, we'll definitely do this again soon. Everybody out there, thanks for your comments. We appreciate it. This has been Insight Live and the IT Experts Take. If you'd like to know more about what we do at Insight, there's lots of interesting information up at solutions.insight.com. Please look us up there, and we'll see you next time. Thanks, guys.
Thank you.
Thanks, Jason.